Idiopathic is the Piper's theory. Counterterm makes a parameter shift, which is the renormalization for the Piper theory as a very simple examples. Follows the compatibility with the Schwarz Parkin's textbook. So first of all, we can construct the Piper theory. There are some of the pre-color fields and the interaction fields are given by the pi person with the coupling constant, and all the parameters, the mass and the couplings are paired parameters with the index zeros. And also the build is also paired build, and we will define the renormalized build with the build strength chart. Then the propagators, the PyPy has the build strength of the charts in the numerators, but the renormalized build doesn't have the such a build strength. And by definitions of the relation between the paired build and the renormalized build with the constant of the build strength, we can rewrite the Lagrangians with the renormalized build, and there will be some build strength will be appears as a chart, because the such as the fields will be the changes renormalized as the base. There are also just here. And we will define the shift of the each parameters is the paired parameters minus physical parameters. So there's a shift delta just, delta m for the mass, delta lambda for the coupling, as the paired mass minus physical paired mass and paired parameters minus physical parameters. Then we can calculate the physical parameters as the paired parameter minus the parameter shifts. So to be specific, we can write the such as the renormalized build, normalized build. Lagrangian in terms of the renormalized build can be decomposed as a physical parameter term and the parameter shift term. And such a parameter shift term is actually the counter term, delta jet and delta m and delta lambda. And such is the counter term shifts is actually can be represented with the Buyman diagrams as the counter terms vertex and the counter term propagator. And we can read of the Buyman rules of the counter terms directly from the counter term factors in the Lagrangians. For example, the counter terms of the phi4 vertex is just data lambda, and so we can read of the propagators of the counter terms, the Buyman rule from the Lagrangians. And then we can define sort of the physical parameters, which is the renormalization condition as the initial conditions. For example, the physical mass is defined at the locations of the pool, which is the denominators of the propagators is 0. And we will define sort of the physical coupling constant lambda is as equal to the ball arms here, where is one that belongs to variables, and other t and u is equal to the zeros is defined as the physical couplings of the lambda. And the remaining problems is how we can calculate and obtain sort of the counter terms. It is to come from the loop integrals, especially we will focus on the one loop, and because of the loop momentums does not have the upper boundary in the momentum integrals, there will be some divergent part will be there a piece, and we can remove sort of the such a divergence by adding sort of the counter term. So there is a very important point. First of all, the counter terms is introduced to remove the divergence. That is the first important rules of the counter term. And as a result, if we add the counter term into Lagrangians, there will be the parameter shift will be appear, so-called learning coupling or mass changes normalized mass. So we will calculate sort of the one loop for the Piper theory. Possible we will focus on the Bohr vertex. The three levels diagram, and there will be the one loop diagram with the S, T, use HANA, and we will ask this counter term for the tax. And corresponding S matrix can be calculated by the Byman diagrams and the Byman's rule. For three levels, there are the lambda, and the one loop levels, there are the lambda scales with STU channel, and there will be some of the counter terms that will be added. Under such a one loop S matrix case can be written as the loop momentum. There's a case K minus P square, and that such a loop momentum K will be integralized out. So only the one momentum remains, and because such a loop momentum does not have upper bound, so it will be divergence. So we will introduce sort of the regulator, and by the normalization conditions, the one that S equal to the Bourham's case and the T and the U equal to the juice, it should be the physical coupling constant lambda, and from that we can calculate that the counter terms as in terms of the as matrix values of the one loop level and it will be the divergence. So such a one loop diagrams as matrix is divergence and the counter terms divergence and is exactly cancelled out. The divergence of the one loop still can be removed. And I want to talk about some of the loop integrals. There's S channel, T channel, U channels, and I just take out from the just one component, such as K two propagators, K square minus M square, and the K plus P square minus M square. And it can such a loop integrals can be calculated through with the Feynman's identity or dimension regularization and weak rotations, and divergence can be represented through with the one over the epsilon, where the epsilon is 4 minus d. These are dimensions, and if epsilon goes to 0, such one of epsilon terms are divergence. The one loop diagram contains sort of the divergence term. So from that, so we can obtain sort of the counter term for the coupling constant, because we obtain the one loop level S matrix the V, and if we insert the S equal to Bourham's scale and the T is equal to and the U equal to the G, then the counter terms is represented in terms of the one of the epsilon and the remaining constants. And from the S matrix, counter terms and the one loop diagrams exactly cancel out one over the epsilon, one over the epsilon. So S matrix has a finite regions. So counter terms removes the divergence of the S matrix in the one loop model at one loop levels, and also counter terms steps of the parameters of the coupling constants. The second example is of the two-point correlation functions. The two levels is just the propagation, and the one loop levels can be represented as the 1PI's diagram, and there are also counter terms will be added. And such as the geometric series of the 1PI's, so, there will be some 1PI's actions will be appeared in the denominators of propagator. And because of the renormalization conditions, such as amplitude should be equal to juice at the pole. Also, one derivative of the armed keys at the pole equal to 0. And by the such a both conditions, we can obtain the counter term for the mass and the counter term for the renormalized normalization strength chart. And the result is given by delta chart counter for the renormalized trunks is equal to 0, and the terms are given like that. And from that, such is as matrix of the two-point correlation functions is finite, and also very strong chart and the mass arm, such as parameters are shaped by the counterterm. So the adjustment regimes of the renormalization with the counterterm, which is makes the parameter shifts and removing the divergence in the one loop.